Hello and welcome to my YouTube channel. Today we are going to discuss about the fundamentals of direct memory access peripheral, also known as DMA. This is a two-part video and this video is the first part of the two-part video. So first of all, let us try to understand what DMA is and what are the features of DMA and how we can use them in our projects. So basically, DMA or direct memory access peripheral allows different peripherals inside the microcontroller to communicate with memory or vice versa without CPU intervention. So this is the most important part, that for the communication or data transfer between memory and peripherals, CPU's intervention is avoided when we can use DMA. So the purpose of DMA is to allow data transfer between peripheral to peripheral or memory to peripheral or peripheral to memory. And during all this data transfer process, the intervention of CPU is not there. That means CPU can do some other task when the data transfer is taking place between peripheral to peripheral, peripheral to memory, or memory to peripheral. So how DMA basically works? So DMA is a controller in itself which manages the data transfer between the memory and peripheral and vice versa. So the different modes in which the DMA can transfer the data are burst mode, in which we can transfer a block of data. Okay, so a set length of data or set size of data is transmitted in one go. That is called burst mode. Then we have cycle stealing, in which the data transfers from a unit time only. That means data transfer can take place only for a unit time. Secondly, or the last, is block transfer mode, in which the transfer take place between a complete block of memory before CPU regains the control. So what is the normal functioning of CPU in a microcontroller? We know that CPU's basic task is to take input, then process the data, and then provide the output. So basically, most important part is here processing. So CPU should be used more for processing purpose. So in general, for example, if there is something in the memory, or we can consider in this example SRAM, and we want to print that data on UART, in that case, the CPU can read the data from the SRAM and then send it to UART for printing purpose. Second option, suppose we have a peripheral ADC which sends the data to CPU. Then CPU processes the data from the ADC and then sends the output to DAC pin. In this case also CPU will be involved for processing the data, reading the data, and sending the data. There might be conditions when one GPIO pin wants to send its data to another GPIO pin also. So in this case, again CPU will be involved, and we can see if this process is followed, then assume if we want to transfer a big chunk of data between any peripheral to peripheral or peripheral to memory or vice versa, then CPU will be always busy. Remember, if the data is too big, then CPU will be always busy. And we want to avoid such situations, because if CPU can be utilized more intelligently than just transferring the data, then it will be more fruitful for any project. Therefore, we can introduce or utilize DMA, which is present in general in some microcontrollers. So what is DMA going to do in this case? So DMA is a controller which will be programmed to read a data from memory and transmit it to peripheral. So this cycle may keep on continuing depending on the mode or configuration of the DMA. Secondly, it can also read data from peripheral and send it to another peripheral. In this case, it may be ADC, DAC, UART, timer data, and so on. So in this way, DMA can transmit or read some data from the peripheral and transmit it to another peripheral. And last but not the least, it can read data from one memory section and then send it to another memory section. So in this way, we can see the data transfer is taking place, but without the intervention of CPU. So the designer can utilize CPU for other important tasks. So CPU can be used for other important tasks. For example, reading the inputs from interrupts and processing the data, and so on. So in this way, DMA can be utilized to obtain a better performance in the microcontroller. Now let us see some of the features which are available in the DMA of STM32F44 6RE microcontroller. So DMA present in the STM32F44 6RE microcontroller can increase the performance. Like I said before, it can free the CPU to perform other tasks or redundancy based tasks, and therefore we can increase the performance of the overall project. Second, it can help us for real-time data processing. Because CPU is not involved in the middle, we can directly transfer data from one peripheral to another peripheral and so on. And therefore, any application requiring fast data acquisition can use DMAs. It also improves the power efficiency. So it reduces the CPU's wake-up cycles or involvement of CPU. So it can reduce the power consumed by the overall project. DMAs can have multiple channels. So parallelly, they can stream data between multiple devices or multiple peripherals. It has got the facility for flexible configuration. Therefore, for various peripheral to memory and memory to memory, we can have different types of configurations for transferring the data. And of course, it can allow from data from memory to memory transfer, or we can say a chunk of data can be transferred from one memory location to another memory location without intervening the CPU. So it allows us to efficiently handle or manipulate data between different memory locations. What are the different applications of DMA in embedded systems? For that, DMAs are generally used for data acquisition, where we need fast data transfer from sensor to memory. That means the data of sensor can be directly saved into the memory in much faster way without intervening the CPU. Second, it can be used for audio or video streaming. We know that for audio or video processing, we need lots of data for the audio or video streaming. In that case also we can use DMA for continuous data flow management without CPU's delay. Last but not the least, we can implement different communication protocols using DMAs, and we can efficiently handle protocols such as UART, SPI, I2C for data transfer using DMA. With this, I would like to end this video. In the next video, I will show you, or I will demonstrate how we can use DMA for transferring data from one peripheral to another peripheral without intervening the main CPU. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the intimation as soon as I upload a new video. If you have not liked the video, then I would recommend or request you to please like the video. If you have any suggestions or comments about this video, then please share your comments and suggestions in the comment section. Thank you and have a nice day.